Hello, everybody. Welcome to my presentation. My name is Austin Murphy, and this week we're looking at SSH. We'll start off with the technical research, and I found out we can use GIFs in our PowerPoints. So what is SSH? SSH by default is going to be installed on Linux in the user binary SSH directory. Some basics about SSH. It's a protocol to communicate with other computers. So similar to HTTP or HTTPS, FTP. Um, SSH stands for Secure Shell, and we can do almost anything from a remote computer that we could do in front of the desktop. By default, it runs on port 22, and traffic is encrypted. That's what makes it Secure Shell, as opposed to Telnet, which is an insecure shell sent in plain text. So when using SSH, we'll mostly use it in a terminal or a command line interface. There are ways to use a GUI through X11 forwarding. It can. It sounds easy. I've had issues with it. We can transfer files over SSH as well using scopy on Linux, and on Windows we'll use WinScopy. FTP the file sharing protocol also has an SSH implementation. And FileZilla, popular file sharing client, can be used with SSH and set up fairly quickly. SSH is a client server technology. So on the client, we'll install SSH. On the server, we'll install SSHD, and the D stands for daemon. And the word daemon means that it's a service that runs in the background. And each of these will have their own config file that we can edit. So SSH has multiple authentication options. We can use a password, and a more secure way to log in would be a public-private key set. And SSH also uses host-based. In the known host file, it keeps fingerprints as a way to identify computers. When we first log into a computer from a client to a server for the first time, it will show us this error message. It's saying that it doesn't recognize the computer. We've never accessed it before, so make sure you trust it and then select yes, and you should never see this again. So we can use SSH for a lot of services as well. On this slide, I explain how we can use it on GitHub and on Linux. All of our keys are stored in the .ssh directory of our home directory, and we'll remember that the dot means it's a hidden directory. So in order to see it, you'll have to allow hidden directories or use the TAC A option and when we're listing the files. And so first, to use it in a service, we'll generate a key pair using SSH keygen, as you can see on the screen. And this will create a private key ID RSA and a public key ID RSA.pub. Now we're gonna go on the server, and we're gonna put that public key on the server. So you can use this in a service, like I said, GitHub. We can also do this on just any SSH server that we're going to be logging into in the authorized keys file. So the admin will create a user for you and a directory in your user home directory, that will say authorize keys, and we'll place our public key in that file as well. Um, we'll add the key to the SSH agent you as I show the directions up here. And so, okay, like I said, we can add it on the SSH servers or a different service. So on GitHub, for example, in this image, we go in, we click, and under settings, add SSH key, and we upload our public key. It's that simple. So how can we make SSH more secure? What are some hardening recommendations? I always think of Pokemon when I hear that. So we never want to use a root login for SSH unless we have to. And like I said, admins will need to create a new user on the SSH server for our user clients. This is how we can do that. Most of us have been through, know the steps already using the add user command. This shows how we can add our user to the sudo group. And this shows how we can create, if there's not already an authorized keys directory on the server, we can create one and add our public key in there. We can either copy and paste or use scopy to transfer. And this is an example from one of my instances. I'm just catting the public key. This is what it looks like. It has our username, host name at the end, and this key here. So to disallow root login, there's one more step we'll have to do. We'll go into the SSHD config file, find the permit root login directive, uncomment it, and set it to no. This is my example. I had it set to prohibit password, but then I changed it here to no. Prohibit password is a way to allow root to use a public private key, but not a password. But it's most secure to do it this way, right here. We can also disable password login for all users and require the public private key by adding a password authentication directive and setting it to no. So that's just another way to make SSH more secure on the server is to restrict our max login attempts. That way, people can't brute force our accounts. We'll go back into the SSHD config file and uncomment the math, the max auth tries, and we can set this to whatever number we want. I put 3 and restart the service. And then we also, a good idea is to time out our clients, our inactive clients. Go back into the SSHD config file, uncomment the client alive interval directive, and set it to however long you want. I put 300 for 5 minutes, and restart the service. And that is this week's presentation. Here are my references. You have a good week.